Passive solar heating is an important strategy in green building design. And please notice this main point on this first slide. This is really a key idea. The building is the system. You are going to encounter that idea again when you think about passive cooling and when you think about daylighting. It's true of passive solar also. The building itself is the system. Dr. Lechner at Auburn University developed this diagram, this hierarchy, and since then the AIA and others have taken to this diagram. You're going to see it a lot. But what it says is the most important thing to do when designing a building is just the basics of the building itself. Once you've got all that as good as you can get it, then you move on to any other details of the passive system. And finally, after you've done everything you can possibly do, then make up any difference that you can't meet with mechanical systems. And the idea is, even in a commercial building, your mechanical systems will be much smaller if you've done the other two tiers first. This is not a new idea. We've already looked at Mesa Verde down in the lower right corner. Chaco Canyon, the Pueblo Bonita people in New Mexico used solar heating. Roman engineers used solar heating to heat their water for their baths. And we use it today. And these are the two primary elements of solar heating. I want to note that you have an assignment today where you're going to go look for some green building, whatever green building you would like, of your choice, and identify whether you think that building is heated with passive solar or not. And here is the way you tell. Does it have windows facing south? Does it have thermal mass? That's the key. Department of Energy breaks it down a little bit more and says, well, really, if you're thinking about a system, we've got 5 elements in this system. The collector is the window, so the window and the thermal mass are the most important. The collector is the window, it faces south. Then the thermal mass has a surface on it, that's called the absorber. And if you want it to absorb solar radiation, you make it a dark color. Then you need some way of distributing the air through the building. So it might be the shape of the building and whether heat rises and so forth. And then for the controls, notice that these are taking the place of the mechanical systems. And for the controls, you have things that you already know about, like roof overhangs and so forth. The windows are in the northern hemisphere, are on the south side of the building, and they need to be within 15 degrees of true south. They'll still work if they're off by 15 degrees. This school down here, Sidwell Friends, is a real famous, I think it's a LEED Platinum, and we'll look at this again throughout the term. It's not true that more windows are better. You run the risk of overheating your room. So you need to have the right balance of window area, floor area, and thermal mass. However big your floor is, make the windows somewhere between 8 and 15% of that. So for example, if your floor were 100 square feet, a 10 by 10 room, then you'd want 8 square feet of window area. Let's think about the type of glass. You are probably already familiar with something called R value. R value is a measure of, R stands for resistance. R is a measure of how well something resists heat flow. And we think about things like insulation. What is the R value of our insulation? U value is the inverse of that. It describes how well something conducts heat. So for example, if you had a wall with an R value of 20, its resistance is 20, then its U value is 1/20, or 0.05. A big R value is good, a small U value is good. We use U value to describe windows, R value for walls and insulation, U value for windows. The rating panel label that you see on windows will have several kinds of factors on it. One of them is the U value. Another one is solar heat gain coefficient, and that measures how well solar energy coming in through the window gets turned into heat. On the south side of your building, you want a high solar heat gain coefficient. So you want a high number. On the north side of the building, you don't have sun coming in. You want a low U factor because you don't want heat escaping through your windows. And then on the east and west, about the same window area, a lower heat gain coefficient. You might think that skylights in the roof would be good for passive solar heating. It turns out they're terrible for passive solar heating because in the summertime, when the sun's rays are coming straight down, that sun beats in through that skylight and heats up your room when you don't want it to. Then in the winter, when the sun is low in the sky, it comes in the skylight at an angle where it doesn't really do that much good, and depending on the skylight, you're likely to have some heat loss. So instead of a skylight, if you would like light coming in, you might consider something called a clear story. That's how it's pronounced. Clear story is a vertical window up above the wall, just under the roof. You can see some great examples of clear stories in the Market of Choice at 29th and Willamette. There's a clear story facing south. And not only does it let in sun in the wintertime, it also is good for daylighting. So windows facing south is one device you need. The other big device you need is thermal mass. Something that's heavy, like concrete or stone or that kind of masonry. And Dr. Lechner at Auburn University has done some research and has found that thicker is not better. It turns out that the most efficient thickness is between 4 inches and 6 inches thick. After that, that's fine, but it doesn't really do any more good, so save the money. Thermal mass can be on the floor, that's what we see here, or it can be on a wall. And it provides a thermal lag, just like we saw with big bodies of water, like the Great Lakes or the ocean. Thermal mass in your building provides a thermal lag also. So you get a more even temperature, heating and cooling. You also shift the demand for energy to off-peak periods because of that thermal lag. And that's good for keeping the demand for new power stations down. If you were to have small thermal mass, so let's say you forgot to put concrete on your floor or on your wall, you would but you have passive solar going on, you would wind up with big temperature swings because you don't have that thermal lag. And then if you say, oh, well, I'll fix that, I'll put in big windows, no, your temperature swings will just get worse. So big windows, small thermal mass, bad. Where can you put thermal mass? One place you can put it is on the floor. And if you have sunlight coming in through the window and striking the floor directly, you probably want a dark surface so it'll absorb more radiation, and not carpeting. You want it to absorb the radiation. You can also have thermal mass on the wall. You could have the sun striking the wall directly if it's a tiny room, but you might want to have a light-colored floor so that the sun's rays come in through the window, reflect off the floor, and go back to the wall. And then the wall can be a dark color or a medium color. Some walls are not thermal mass. They might be sheetrock and that sort of thing. And those walls can be any color, but if they are a light color, they will work well to bounce light back into the room, which is good for daylighting. Then, as you are familiar with now, you want shading on the south side of your window. And we've used the sun angle diagram to figure out what angle the sun is going to come in, and that's going to tell you how long an overhang you ought to make. You can also put deciduous trees on the south side, and you may have other devices. On the east side of the building, it's okay to have morning sun coming in. That'll probably be pleasant. On the west side of the building, however, that sun gets really hot in the summertime. Down here in the lower left corner, we're looking at the west side of the Health and Wellness building at LCC. And overhangs are not going to do a lot of good, but you might want to consider vertical wings. And you can see that the architect has put these vertical perforated metal walls here. This is a medical center that has vertical wing walls. Passive solar heating is going to do a lot of good things for us. It is a way to help address the climate change issue by minimizing greenhouse gas emissions. But just from a personal perspective, as Dr. Lechner says, pipes will never freeze in a passive solar building, and people will never freeze in a passive solar building. So even if the power is out, you are going to be comfortable within reason. And here are some sources for you, including a couple of websites.